Good afternoon. My name is Michael Wallent. I'm a general manager in the Windows division at Microsoft. Let's see. There we go. This works. And I run the Windows client platform team, what you may have heard of as the Avalon team. Just by way of reference, how many folks here were, if any, at the PDC last week in LA? Nobody. Okay. Excellent. Which means I can say whatever I want. So since we actually have a pretty small group, let me just tell you a little bit about what I think I was asked to talk about and make sure that actually is what you want to hear about. So I was given the task of presenting the Longhorn client architecture. Relatively broad topic. And I picked 14 or 15 slides that I thought well represented that. What I was going to talk about is talk about some of the approaches that we took in building the Longhorn client from a platform perspective, and also talk about the three main pillars we think about from a developer perspective in Longhorn. Wasn't going to focus a lot on interop in terms of how we go from where we are today to where Longhorn is, but try to give you more of the big picture of what Longhorn actually is. If people think that's a bad idea, or they'd like to hear about something else, happy to take a question and try to re-vector the presentation, and we can talk without slides, without a net, and try to make it a little interesting as our after-lunch speaker, given that the last speaker didn't show. At least that's what I heard. Any comments, feedback, questions? Worst idea in the world? Okay, we'll just press on then. I love talking at 2 o'clock in the afternoon. Anyways, so if you think about the approach that we took in Longhorn and the way that we motivated doing what we were doing, there was a really fundamental difference in what we're doing now versus what we've done historically. Historically, the way that the world works at Microsoft is that there's been the systems division, which produces Windows, and then under various names, the developer division that has built tools. And the job of systems has been to build a bunch of code that people in Windows wanted to use, typically the shell team, to build the Windows shell, and then to hurl it over the wall, generally across the street, because the people in systems sit on main campus and the people in dev sit in the big tall buildings to the side, 40, 41, 42. So we throw it across the road, and they build wrappers on top of it. Visual Basic, ATL, MFC, Windows Forms. And there's the Windows way, and on a different schedule, there's this developer tools thing. And the tools come with runtimes, and the runtimes are the things that people actually develop to in general. And yes, a few developers, a small subset of developers, may write to the low-level APIs that are exposed in Windows, the Win32 API, but in general, those Win32 APIs are exposed only through wrapper layers. So we've done something completely different this time in Longhorn, which we think has a series of benefits for developers, for architecture, for basically building better apps, which is that we have taken the big bet on managed code. Basically, Windows is being written in managed code. Huge bet for the company. So my team, I manage about 400 folks, have about 150 developers. On a daily basis, somewhere between 130 and 140 of those folks are writing managed code. 24/7. And so I got to tell you, sometimes they do work 24/7. So from an architecture perspective, the real significant difference that this brings is an integrated stack, an integrated system across the board where developers can choose what layer to plug into without the typical cliff that had appeared previously. Let's take, for example, and let me drill into this a little bit. Let's take, for example, the example of the Windows Forms button. Right? Well, how does the Windows Forms button work? Well, we have a managed class, but it's sitting on top of the underlying Win32 user implementation. There's a set of properties that have been wrapped with managed code that you as a developer can change and set. But if you want to go outside of it, and let's say, for example, that, well, I don't want the color, the background color of the button to be a pure color. I want it to be a gradient, or I want it to be an image. Well, if that's not exposed, then we're into hooking the WinProc in order to make that work. So there's this cliff between managed code and kind of what's underneath. Our goal with Longhorn is to architect the entire system, presentation, database, communications, so that there is that complete stack. You can choose where to plug in and get the exact behavior that you want without ever switching language, without ever switching mode, without ever switching the way that you design your application. So we think that's a big bang shift in the way that people think about building applications for Windows, and the way that we think about building applications for Windows as well. Because as you think about the capabilities exposed to you as architects, as developers on the system, you're not simply talking about a Surface API layer, but essentially the entire stack of the system is available for you to build and reuse in toto. You think about it, my team, Avalon team, the user interface stack that we've built. It's not like we have a set of controls that you can reuse, because we do. And that's all you get. But you can go down to essentially the subatomic level of those controls and decide how to replace and rebuild and refactor those to create the experience that you want. So we think that's a real shift in the way that people think about using Windows, because all of the components are available to you all the time, not just a subset at the surface layer. So this is, in many ways, the big bet for Longhorn. Betting on managed code, building this consistent stack, getting consistent APIs, getting consistent model across the board for not just the 400 guys doing a presentation platform, but the 10,000 plus people in Windows and in DevDiv who build the platforms and tools that developers use on a daily basis. And since we have a nice small crowd, I'm happy to take questions as we go along. So if you have a question you'd like me to answer, please raise your hand, and I'm happy to take it. Yes, sir? Are we going to see a demo of Longhorn or Avalon? Question is, are we going to see a demo? I was not going to do a demo. No. That would have been a good idea, though. I was thinking many of you would have been going to the PDC last week, for which Longhorn was there aplenty, but other questions? Okay. So let me talk a little bit about the architecture and some terminology. So the way that we think about the new API set in Longhorn, we call it something, well, we call it WinFX. Essentially, WinFX is the new managed code APIs for Longhorn. We think about four main areas inside of WinFX to be concerned about. Presentation side, codenamed Avalon. It includes more than just the new user interface stack we built, but it also includes existing user interface technology, such as Windows Forms. In the data, in the WinFS side, new file systems, new schemas, etc. On the communication and collaboration side, codenamed Indigo. And then built on the set of fundamentals that kind of the whole system as a whole is built on, the base class library, existing objects that kind of persisted from existing versions of Windows. WinFX really is Longhorn Plus. So we're trying to think about, well, for the new set of APIs that are built that work on Longhorn plus its follow-on releases, that's what we call WinFX. There will be parts of the .NET framework that really are in the fundamental section that exist and live on down-level versions of Windows, Windows XP, Windows 2000. But our new push essentially is to create a new beachhead where we add additional functionality into the platform, and that requires a new version of Windows. Much of the functionality in Longhorn will not be made available onto existing versions of Windows. There are some fundamental reasons for that related to the architecture of the system, and I'll get into that a little bit more as we go forward. But essentially taking the Longhorn API, WinFX, and putting it onto Windows XP would essentially be upgrading Windows XP to Windows Longhorn, because it requires a full new stack where you essentially might as well upgrade your operating system at that point if you drop it down level. So we think about, oops, that was backwards. no build. So the slides which you'll have and which we have posters of, which you can probably get hold of, the Longhorn architecture talks about different various areas of the system and drilling into those in terms of what's available for developers. Everything you see up on the screen here are managed code objects which you can use in a way that you'd expect using managed code. Don't want the happy build. So I'm going to talk about the three major areas of investment: presentation, WinFS, and collaboration, Indigo. So the presentation team, as I mentioned, team that I run, and really one of the challenges that we faced in doing this is that our team was really formed out of two groups. One that did internet technology, Internet Explorer, and another team that did kind of intrinsic Windows functionality, user, GDI, et cetera. So we had a team that was all about the internet and a team that was all about kind of Windows core internals. And what we tried to do is to really meld them together in a way that brought together the best of the web and the best of Windows. So fundamentally, the first thing, and this really goes across all the pillars, is that there's this fundamental aspect of building smart clients that we needed to fix in order to make any of this rational again, which is around deployment. We realized that many people have made the choice, and probably many folks in the room, to architect their systems around HTML clients and smart servers because of the deployment issues. Right? We use Outlook Web Access, great example of a deployment application in that fashion. Uses the browser, no deployment, just go to a website, it just works. Microsoft introducing a smart client solution that required deployment, hard deployment onto multiple machines, just it's a non-starter. So when we think about the best of web and the best of Windows, certainly one of the things that's best of web is zero deployment, but having zero deployment of smarter applications. Which kind of brings us directly into another challenge we were trying to face, which is going back to the Outlook Web Access example. I get into this weird application model issue, and this is even seen more forthrightly in many line of business applications, where I go to my URL for Outlook Web Access for mail, and I see essentially the two-menu problem. I've got the browser menu, the browser toolbar, and then I've got the menu in the toolbar for the app that I have inside. This weird merging of, well, the browser's menus and my application's menus. And from a user perspective, when do you use which one? You know, file print, where do I actually print from? Do I print it from the browser? Do I print it from my little printer button on the inside? It's confusing from an application model perspective. And then how many times have you gone to, a line of business application on the inside where you browse to it and it's got the full-on menu, the full-on toolbar, it's got its own address bar. That's one of my favorites, when it's got its address bar internal to the application. And the user hits the back button up on top and it dumps the app. And you lose all the state. From an application model perspective, it's kind of a disaster. So the fact that the application model which is in the browser, was coupled to the deployment model, go to an URL, have it just work, is broken. One of the fundamental changes we made in the presentation system is to decouple the application model from the way you get it. So I can go about and browse to an URL and have a window pop up, which is a windowed app. Is it related to the way the security works? No. It pops up. It was a choice that the developer made in the manifest. I can go to the Start menu and click on something and have it start up in the browser. If it's a browser-based, navigation-based application, there was too much coupling going on historically, where we coupled the navigation metaphor to the security metaphor to the deployment metaphor. Those things are broken apart. So we wanted to solve deployment, but at the same time, we needed to solve application model and make that credible. So now, when you think about building a Longhorn application, it is a choice in the manifest, a declarative choice to decide whether it pops up in the browser, in a separate window, and you can decide whether it navigates, doesn't navigate, etc. It's up to you to decide to build the right application the right way. You choose deployment, you choose the app model, you choose whether it's navigation or in the browser. It should just work. So those were kind of two top challenges around best of web, best of Windows to resolve. The second thing is, and if you've seen any glimpses of Longhorn, and I apologize for not coming with a demo of Longhorn. It's an oversight on my part. We've tried to make Longhorn, and we have a vision for Longhorn around finish. So there are demonstrations that we show that do some animations. Historically, lots of different packages have tried to do animations, sometimes better, sometimes worse. But it turns out that what we found is that the cardinal sin on doing any sort of animation isn't how many frames per second you can show or how flashy it is, but it's glitching. If you glitch, if you drop frames when you're doing an animation to try to convince the user that it's smoother, it's more polished, you lose all the credit and you get negative points because you've somehow dropped a set of frames. So there's a whole push in Windows Longhorn around presentation and fit and finish, making sure that the look and feel of the application is solid, that if you do something, do it well. As a result, in order to do something well in many of those cases and not chew all the CPU for these higher-end graphics effects, we've gone down the path of utilizing the GPU far more effectively than ever done before. So just as a little point of reference, and I don't know how many folks are aware of this, but so today you can go to the store, you can buy a $1,000 machine, and it probably has a 128 meg separate graphics card on it. That part probably cost a couple $100. Expensive part. When you're running Windows, just full-on Windows, Windows Shell, Windows XP, you're running Word, you're running Internet Explorer, of that 128 megs of graphics memory, we're going to do a poll in the audience because it's after lunch, and after lunch is always a great time to do polls. How many people think that of the 128 megs of graphics memory, running Windows XP, running Word, running Internet Explorer, we're using 64 megs of that or more? Hands. Nobody. It's good. 32 to 64. Anybody? 32 to 64? 16 to 32. Okay. 0 to 16. Well, it's about 2. Because the only thing that's being done on the GPU is some of the text output done through GDI. If you're using GDI+, oh, sorry, not accelerated. If you're using some other technique to put text on the screen, not hardware accelerated, not using the graphics card. So you got this big graphics card, essentially idle, with all the memory idle, just not being used. Well, it turns out that we can actually use that graphics card to do useful things like text. You know, if you've heard Bill talk in the past 2 years, how many folks have heard the words subpixel clear type come out of Bill's mouth in the past 2 years? I certainly have. I hear it every time I talk to him. Right? Bill loves subpixel clear type. What subpixel clear type does very quickly is when we put the text on the screen, and it's an LCD monitor, as you know, we have the ability to align text not just on the pixel boundary, which especially as you have high resolution monitors, becomes too large to really do anything useful. It kind of looks, gloppy after a while. We can align the text on a subpixel boundary. So it means we could start it on a red pel or a green pel or a blue pel. So we can align it and we can do clear type around it, which essentially, to my eye, makes it a little bit fuzzy. Nevertheless, it increases the readability significantly because it gets rid of the jaggies on the text. It effectively doubles the resolution of the screen from a reading perspective. Kind of interesting. So we can actually use that graphics card to display subpixel clear type in a hardware accelerated fashion. You can imagine this is important because text speed is something that we care a lot about because a lot of text gets displayed. And when you're doing funky subpixel alignment of characters and you have to do background masking on the background to get the color right, because you can imagine putting things across the pixel boundary, you get some weird color bleed effects. So you want to hardware accelerate that a little bit because it gets a little slow. So the new presentation system, when it does text, always does it in a hardware accelerated fashion. So we can get text done way faster. We can animate it. We can display it. We can have it not flicker. I'll just tell one apocryphal story on this. So I ran the Internet Explorer team for 2 or 3 years before we picked up this team, and did Trident specifically, which was the display engine for that. And we were pretty proud of Trident. It does HTML display pretty well. And we thought it was pretty fast. So I'm sitting at my desk one day, and I get this call from a developer on the DirectX team. And he basically says, you know what? You guys stink. Why? We thought we were doing pretty good. We thought 98% market share was a good thing. He goes, no, you stink. Because I can run my favorite 3D game, whatever, Quake, and have it be this photorealistic environment in a real world, and you can't scroll text without tearing it. So you stink. It's like, okay, we stink. We're trying to fix that. We don't want to tear. We don't want to drop frames. We don't want to glitch, because that makes the experience look clunky. When you minimize the window and you maximize it back up and you see through the window to see in the background of it, there's no call for that. So that's the type of fit and finish that we're really trying to work on to make that work. In order to make that work, besides going to hardware acceleration, to make the graphics really sing, we've needed to build a vector-based engine for doing effects, for doing animations, for doing all of our graphics. Vectors help us to a great degree because we can talk polygons to the graphics card, and again, hardware accelerate many of the effects. Many of the effects that you see on the screen for Longhorn, if I was demoing Longhorn, you would see are accelerated, are very smooth, they're running at essentially 60 or 80 frames a second depending on the refresh rate of the monitor, because the graphics card is essentially doing them without interference from the rest of the stack. Brings us to performance and interactivity, having that interactivity, having the performance, making sure that the graphics appear natural, appear integrated. And also making sure that we have applications that can run online, can run offline, or both. Part of that deployment model that I talked about before, just because something runs in the browser doesn't mean that it can only run online. That's kind of a wacky model. We want to make sure that you can run something in the browser, have it be offline, and have it be up to you as the developer to decide, or the architect to decide, well, based on the configuration of this application, how much data I bring down into WinFS for me to use locally, how much I just require a web service to make this work. You don't expect that Amazon is ever going to build an offline version of Amazon. Doesn't really seem reasonable, because that book catalog is their IP. They don't want to have it offloaded anywhere. It's just not reasonable to have that be offline. But they want to have the flexibility there where you can decide how to do that. Yes?
What benefits will there be for existing Win32 standard GDI?
Okay. Existing Win32 apps. So we're pondering around that one. If you do nothing, then likely what you will get is you'll get the same 9-grid themed app done with bitmaps that you had before. Except instead of it being green, like Luna, it'll probably be blue, like Arrow. That's about it. It's going to probably be about the same. We hope to expose a set of APIs that are easy for people to convert and kind of move up to. For example, new versions of something like xTextOut, so you can replace your text output calls with new Avalon Mill graphics calls to get subpixel hardware accelerated clear type. I think one of the challenges, and maybe if this is what you're asking, I'll answer it a little bit more. One of the challenges is, in Windows XP, how you had to decide in your manifest what version of COM control you wanted to decide what look you wanted, whether you got the Luna look or the classic Windows 2000 look. Same sort of model here. You can specify what version of COM control you want to decide whether you want the existing Luna look you had or you want the new Arrow look in the new shell. So the real essence of it is you might get theme changes, but that's about it. You're not going to get a lot of benefit. I'll talk about high DPI in a second because that is critical as well. But more than just flashy buttons and more than just animations, we haven't gone down the path of thinking that this is a huge opportunity to migrate from a Win32 user-based dialog or form or a Windows Forms form to an Avalon form, because just migrating it from a set of buttons laid out on a form to a set of buttons laid out on a form, whatever, that's not really the point. In the new application model that we're thinking about, it's more interactive with the consumer. It's slightly more wizard-based. We're trying to go away from strict form entry and go towards more user-aided design. Just as a thought there, one of the things that I saw as an experiment in this space, and it does require some experimentation, is a task pane. And typically, you think about in a task pane, the amount of space that you have as a designer is very limited. So typically, they're not super useful. But I saw this effect where there was context-based help being brought in for the user as the user was doing something. And what it was doing was, is underneath the search area or a what do I do next area, it was floating in a line of text which said, oh, based on what you're doing now, you could choose to do this. Or the way to complete the formula is to do this. And it would bring it in, and then after a few seconds it would fade out and scroll down. So it was bringing in context-sensitive help in a way that wasn't jarring to your eye, that wasn't flashing, but yet it was useful, and it kind of made the experience better. So what we think is that, boy, your existing apps are going to work the same way they work because we're not touching GDR user, we're building a new stack. You can get some benefit on theming, but the real benefit is thinking about building the user interface in a slightly different way, in a way that is more directed to the user, is more friendly to a broader range of people. And that's really kind of where that benefit is. And that's something that we've been really experimenting with over the last 6 or so months as the platform has become a little bit more mature and we can start to have people building real apps on it. The changes they've made are more interesting in that the apps they build are different. They try to visualize things in a more interactive fashion. So would have been good to do a demo there. But does that answer your question to some degree?
I'm sort of thinking from a line of business application perspective where we've got a vast portfolio of just standard input into that.
Mm-hmm.
On a like-for-like hardware basis, would you expect them to go faster or slower on the Longhorn engine versus on the Avalon engine versus standard Windows 2000, Windows XP?
So without doing any work, you're going to get the same engine it had before. No difference. Maybe the machine it's running on will be a little faster or run faster. We expect with minor changes you could move to use kind of the low-level graphics calls to make it hardware accelerated, make it a little bit better if you're doing your own graphics engines. If you're doing a charting package, you're doing some sort of data visualization package, if you have a lot of text that you're drawing yourself, using the new APIs could potentially get you some faster performance. But again, we're not saying here's just a new way to do a dialogue. We're saying here's a new platform to change the way you present the information in a way that's potentially more interactive and more useful. Right. I can imagine, one of the things that we've shown before is data visualization packages that aren't just the same old grid or table, but in essence of a 3D package where I can drill in and explore into the data. Just a little more space there. So just a little more drill down into Avalon. I talked about the vector-based compositing engine. With respect to advanced input, one of the things that's clear is that there are multiple form factors coming up that people want to develop for. Desktop PC is great. We love it. We love the mouse. We love the keyboard. Tablet, also really important. And then you get into interesting things like small handheld design, remote control design, voice inputting, international, be it tip encoding, that sort of stuff, and then accessibility issues. So a lot of the input layer is abstracted out to make it a lot easier to build your application to fit on these different form factors. The other big push in Avalon is around something we call XAML, and I'll get into that in a little more detail in the next slide. So on the best of web, best of Windows theme, again, those of us coming from the IE side really liked markup-based programming. The folks not from the IE side thought markup-based programming was for amateurs. If somehow you're using JavaScript and dynamic HTML to build your applications and not doing it with real code, that app was slower, wasn't as functional, had security issues, was ugly. So at the same time, we were real believers in markup as a way to separate presentation and presentation semantic from the underlying programming code. And one of the meta trends that we've seen, even in the line of business space, is the emergence of more thoughtfully designed products. I think about my own experience 15 years ago as developer at a software company doing dialogues. Geez, I'm no artist, but I got to lay out the dialogues and kind of invent my own icons. And I think many of us have probably had that same experience. But if you think about, at least at Microsoft today, and I think at many companies as well, we have graphic designers on payroll. They design the dialogues, they do the colors, they do all the icons. And the way that they do it is they use designer tools. And then they come up with bitmaps or vectors, and they throw it over the wall to the developer, and the developer creates an interpretation of what that means, maybe with some storyboards for what the effect should be as the objects move in and out. It's a somewhat inefficient process in that what the developer creates is often an interpretation of what the designer wanted. It's never quite what we want. So what we were trying to do was to use markup and to have markup-based tools for developers and designers where the designer could essentially build the user experience, create much of the user interactivity, and then hand it over the wall to the developer for the developer to put the code behind it. You know, imagine the login screen for Windows. We'd like to be able to do the login screen completely by designer that gets all the effect right, and the developer writes some code to do the auth on the back end. That's it. Right? And then we can maybe modify the login screen to make it look exactly what we want. Do that again and again and again until we get to the effect that we want. So markup, pretty critical. But the real change from a platform perspective is that essentially all that XAML is it's a persistence format for CLR class instances. That's it. We can compile that markup, that button. What you see across the bottom, those are analogs. Across the board, those are the same. Those compile to the same IL. Now, yes, we can parse XAML. We can parse it real time just like we parse HTML. We can also compile it. We can compile it to another markup format that right now we call BAML, for binary application markup language that's pre-tokenized. Or we can compile it to IL, the same thing that C# or VB get compiled down into. And then I can run it as a DLL. So why would I want to have both markup and IL? Well, for some things, when I'm laying out a form or I'm using a tool to do that, having the markup and not having the IL is way easier to manage. I can persist it, I can round trip it. I know there's no question as to the procedural state of the app. So it's pretty critical. Yes?
So today I can serialize .NET CLR objects,
Right.
I can serialize them in, I can serialize them out.
Right.
So what's the difference?
Well, it doesn't serialize to an XML format, and there's some things that don't serialize super well with respect to state. Like it's not just the single object, it's the tree of objects. You want to have a serialization mechanism to have a tree of objects be serialized. And that is a fundamental difference, and also their interim state. And I'll get into another point on this around composition, which is critical, which this serialization form gets us to as well. So these compile down to the same IL. Now, the reason why I might want to have markup sometimes, just XAML, BAML sometimes, and IL sometimes, is different scenarios. I can imagine in a server-generated scenario where I'm spitting out markup from a server in a very much like an HTML scenario. I don't want to necessarily have to compile that on the server or on the client. I just want it to be parsed. Right? It's the scenario I'm looking at. I might want it to be parsed not all at once, but I might want it to be parsed incrementally so that I can have the effect that I have in HTML where I get partial rendering on screen. I can imagine another scenario where maybe I was pre-compiling the code, the XAML, and I wanted to have a little bit better performance on load. I could persist it into BAML, essentially pre-tokenize it, make it a little bit faster. That may be specific to a given locale, because I couldn't do globalization and localization as easily there. Maybe to a given machine, but it would load a little bit faster, maybe have progressivity still in that space. Or, let's say it was an app that I had just run. Let's say it was part of the Windows shell. Well, there, I just want it to start. It's the control panel. I want it to start as quickly as possible. I want to compile it to IL because I know I'm going to run it. I know what machine it's on. I can pre-jit it. I can do a bunch of code tricks to make sure the code gets optimized properly. It's code. I want it to be code. But I'm able to choose, and I don't have to choose. The cliff thing comes up here. I don't have to choose my programming model based on what I want my app to do. Same programming model, I decide on the back end. Keep it in markup or compile it, your choice. So that we thought was interesting. So the other thing here that I wanted to bring up, and it's kind of off topic for this slide, but I wanted to have 3 slides for Avalon, which is extensibility and composition, which architecturally is an interesting thing to wrap your head around. So we think about the new presentation system as composited. What does that mean? Well, in HTML, there were some controls and some objects for which I could composite objects in. For example, the HTML4 button, right? It's the button tag. The button tag is compared to the input tag, right? Input type equals text has a value property for some text that's inside the button. Input type equals text, value equals some text is an example of a not composited control. The only thing I can put inside of it is some text. It knows how to handle text. That's it. The button tag is a little bit different. The button tag is an open tag. I can put any arbitrary content inside of it. I can put an image, I can put a table, I can put everything. And wrapping the button around it gives it buttonness. It lets me click on it. Now, that has some interesting effects from a programming model perspective. The first problem it creates is that when I have composition and I have a button containing, let's say, text and an image and a table, etc., when I click on the object and I'm trying to write code against it, what's the object I get the event on? Is it the innermost thing I clicked on? Is it the button object itself? Where do I get the event? The eventing model gets kind of goofy. And the programming model gets kind of goofy as well. As I iterate through the objects on the screen, I not only see the top-level meta objects, but I see these internal, essentially, artifacts. And especially if you have some designer building it for you, kind of making it look cool the way you want it to look, if the designer is able to impact your programming model and the code that you wrote, well then there's something kind of funky with that model. So we thought composition was really cool, but we wanted to do composition in a different way. So basically, every single control, every single object in Avalon can be composited. Right? Every single one. But furthermore, beyond that, every single property can be composited as well. So let's take that button that says Halo with the image on it. Not a good line of business example, but it's a great composition example. So it's a button, and there's no subclassing in play here. The background brush property of that button is composited of 3 other objects. The background brush, it's not in the programming model, it's not in my tree, it's the background brush. The background brush is a radial gradient, and it's another gradient, essentially an elliptical gradient up at the top, and then it's an image. And I'm essentially painting the background of the button with a brush that is made up of other objects. And then the button itself is composed of a layout, which does essentially a binding to the left and binding to the right of some text where it says Halo, and then the foreground image. So from a model perspective, I've got a composited brush, and I have a composited object. No subclassing involved. So if you think about the many times that as developers and designers we subclass in order to create funky specialized behavior related to layout, related to look, this gets rid of the vast majority of that and lets us build systems that are far flatter in the approach. But furthermore, let's think about something like a scroll bar. A scroll bar is really made up of multiple other objects. And what if I could truly composite them and not have them be just dead? So I have, a thumb on the top, or I have a thumb in the middle, I have, buttons on the top and the bottom, and I have some sort of tray that it kind of slides up and down, and then probably an outer layout for it itself. But as a developer, if I want to customize the scroll bar, right, what's the difference between a scroll bar and a spinner? Effectively nothing. Right? They both track. They both have something to track in the middle. They just do it in a different semantic. What if they're both from the same class and I didn't have to subclass on that? So I essentially have, the ultimate model view controller model through composition because I'm able to build controls and specialize their behavior without subclassing and without muddying up my system. So we think from a user interface perspective, it's a fundamental breakthrough. And we're actually trying to build all of the controls in our system this way. We see it as a failure when we fall back to WM Paint as a way to build a control. Right? If we have to fall back to Paint it, we've done something wrong. Let's figure out what we did wrong, why the perf is bad, why the design is wrong, because then that means that you can't design your system the way you want because you cannot reuse. You essentially cannot stand on our shoulders, but start standing on our toes, which is always a mistake. So, questions about that? Too wacky for words? Okay. So I'm going to move off a presentation and talk about things that I know less about. So I'll do my best. So when it comes to storage, this, the common experience we have is that, for every application essentially creates its own store. It creates its own way to store data, it creates its own schema, it creates its own information, and I have multiple applications all dealing with the same data types that interact with and deal with data in private ways. The relationships between those objects are hidden except to the applications themselves. And if we think about contacts is always the canonical example in this space. I have multiple applications that have the notion of contacts, but just because I'm both mwallent at Microsoft.com and mwallent at hotmail.com, and I use my email address not just in Exchange or not just in Outlook Web Access, but in Messenger, that's just lost on the system as a whole. And the other big issue we have in storage is the fact that, let's think about photos. Digital photography, great example to use because people do it all the time. Or more and more people are doing it all the time. Think about photos that I would take. I personally struggle with how to actually arrange my photos. And I have this sort of half-baked scheme where I name kind of what the primary purpose was when I took the pictures, plus the date, and sometimes I do it and sometimes I don't. And then, but I really want to have a different slice on it. Like I want to have a picture of all my kids, right, or all scenery. Well, I just haven't arranged it that way. I once talked to a guy who had this, this extreme multi-level hierarchy for describing how he took his pictures, and it was first where it was and then when it was. And the problem was when he went to another country, his scheme completely broke down. It was that complicated. It was wacky. So, but essentially, the view that you have on your objects in the shell are tied to the hierarchy that you create. And once you create the hierarchy, boy, you're a brave person if you decide to change it. And it's too bad that shortcuts don't actually work, because that would make it even better. Now we have the great animation. I didn't do this animation. I'm supposed to say, this has happened. So WinFS hopefully will solve many of these problems. The first thing, and I think the real thing that we're really trying to wrap our head around, is around common schemas. There's a set of schemas that are baked into Windows and Windows Longhorn. Pictures, people, documents, etc. And you can extend those schemas with your own properties, and you can create new schemas. The question is, when, how do I do it, when do I do it? You know what? I don't think anyone is precisely sure about that. But starting to think about how you break down the data into your application into a set of schemas that you would expose into the shell. Right? Because really what we're talking about here is one choice to make is schemas that I expose in the shell. And the second choice to make is schemas that I just happen to store in the database that really the shell doesn't have access to. And there's certainly two different worlds there. So what do I expose as an application provider? What objects do I expose in public schema that the shell sees, that the user sees, that other applications may have access to as well, and be able to annotate and poke data into? Interesting issue to have, but you have extensible schemas. We also want to be able to have view extension in the system. So when you put information, when you have custom schemas, or when you extend the schemas, you're able to plug into the shell and create viewers for those objects. If you've seen demos of Longhorn, you've seen examples of document types where we thumbnail not just an icon for the object, but we thumbnail the document itself. Well, that can't just be for built-in Windows types, because Microsoft Word isn't built into Windows. So we need to have a custom way to have schema viewers, a document schema viewers that can generate an icon. So you can imagine that a method that we would expect to have on a schema with some code associated with it is to generate a thumbnail icon for it. How do you do it? What do you want to expose? What should be in the system? Because of the fact that I'm now not restricted to having data in folders, but data can be in views, and those views can be multiple levels deep, they can be subqueries off each other, and they can be custom, and applications can create them. I can, in many ways, use the shell to serve the function of much of what my applications used to do. If you think about a lot of the work that an application does, especially a line of business application, I'll use a good example here that we use at Microsoft all the time. There's two good ones that come to mind. One is what we call head tracks. Head tracks gives us access to all of our internal HR data. And what is it basically? Well, it's a tree control on one side, and you can click on a person and do some queries, and it gives you a detailed view on the bottom. And then you click on the detail, and up here you see the detail for the person you selected. Well, boy, there's a ton of work in that application related to managing the views on the data. Got a bunch of smart guys in Building 9 doing that for thousands of files and objects, etc. So how would I recast head tracks into exposing those people essentially as public schema that get loaded onto my system and then using shell views on that to do the work? Then, well, what does my app become? Then all that my app becomes is the thing that has the business logic around deciding who can view the data, who can edit the data, and how it gets updated, and what the schema is around that, or what the protocol is around that. So in this sense, the notion of what an application is can potentially radically change, because a lot of the data management kind of can go away. Super interesting issues around branding for ISV applications, right? I'm not even going to touch on that in this space. But the sense of what an application is and how that gets broken down and distributed into the system overall, fascinating issue. For line of business and for training, I think that there's potentially huge opportunities there. Questions on that? Yes, sir.
So, using the word schemas, are these tagged fields, or are you actually saying these are physical tables that you're exposing? Schema would imply tables.
I think it's above the table level. There's not necessarily a one-to-one correspondence between schema and table. Schema is a logical view that may be split across multiple tables. So you don't program to WinFS at the table view, at the relational view. You program to it at the object view, at the schema. You create an instance of the schema. You work on those objects. It's object-centric.
Tagged field?
It's a tagged field.
It's sort of like an XML tagged field?
I believe so, yes.
Okay.
Other questions? Okay. So just a view, and you'll have this about the wondrous objects that are WinFS. There's a lot of them. So my big takeaway on WinFS, just to summarize on that before we get into communication, is think about how to schematize your application, how to integrate it, and then really think about what the identity of the application is and what the work that it does is. That's really the essence of WinFS and how the logical views can be handled by the system overall. So we want to have these applications be able to communicate with each other as well. So this area that we talk about is something we call Indigo. Indigo kind of encompasses our communication and collaboration work. And really, fundamentally, it's about connecting up people and machines together in a reliable fashion. There's certainly lots of challenges that people have today, especially in multiple topography scenarios. Hopefully, a lot of that will be insulated. But again, the architecture of Indigo, going back to the theory we talked about earlier, you can decide at what level to plug in. You can get the highest possible level service where you just ask for a message, you get the message back, or you can plug in, you can control the protocols, you can control the encryption, etc. You can decide how to make that work. Oops, that's the wrong one. One more. So, really, Indigo is about the web services model. We've been talking about Indigo for quite some time. As I said before, you can kind of decide where to plug in, and you can decide how to build clients, how to build servers. Indigo, unlike many of the other bits, does have server components as well as client components, and Indigo is an area where some of this functionality does go onto down-level systems as well. So collaboration, you can think about collaboration as a layer on top of the underlying transport layer. Really the issue here is thinking about people and groups as first-class objects in the system overall, uses some of the underlying Indigo technology to make this work. But from an architectural perspective, having people as first-class objects, essentially just WinFS objects with schema in the system, as well as a set of controls exposed through the shell that you can use in your own applications. Trying to do things like having common schema for the people, having common metaphors to expose all the people in your system so that even if you have people in contacts coming from multiple sources, they can be accumulated together in components we call the people picker, where you can get appropriate contacts across your applications, etc. And there's a set of classes on the namespace diagram that contribute to that as well. There are a set of user interface controls that should be very easy to use related to what we call the people picker, chat controls, telephony, voice over IP work, as well as just data collaboration in that space. So a few things to talk about. The roller coaster slide. So you had a question before about Win32 and that space. So the whole essence of the effort on Longhorn was to create essentially a new stack to the side. We didn't want to touch a lot of the existing work. I'm sorry, the existing things that already work. So your apps that run today on Windows will continue to run on Longhorn unchanged. Our real message to developers in terms of how to get to Longhorn today is to start writing managed code. We have fundamentally made the bet at Microsoft on managed code. We are building Windows with managed code, period, full stop. So in order to move forward and take the most advantage of the system, starting to build on managed code would be a great thing to do. Yes, certainly, we will have COM interop and other interop for unmanaged applications accessing the managed interface. But when we talk about WinFX, WinFX is a managed code API set. And there are certainly ways, as you think about going up towards Longhorn, where you start to use the interop and migration features to use parts of the .NET framework and parts of WinFX in your applications. I mentioned before about the calls to replace your text out or your low-level graphics calls. You can do that. But in order to really get the full-on experience for Longhorn, it's really moving towards a managed code WinFX model. Now, obviously that can be done in stages, and there's different ways to do it. And I'm happy to talk about migration strategies in detail there as well. So that's Win32 stuff will still work. Managed code will work even better. And managed code is the on-ramp towards building fully exploitive Longhorn applications. One other point that I forgot to make before on the presentation space has to do with high DPI systems. You asked before about existing applications and how they work. The one thing that we're doing as well, one of the trends that we've seen in the industry is the move towards, or the desired move towards higher and higher DPI systems beyond 96 DPI to 120, 140, even 200 DPI. The problem that exists today is that as you move up to higher DPI systems, your existing applications, which are designed for 96 DPI, get smaller and smaller and smaller. They become so small, you can't even click on them anymore. In some cases, the buttons become too small. So one of the things that we do is we can stretch those using some composition technology to stretch them out so they appear to be larger sized. So that's one way that new applications will get even better on Windows Longhorn. So that's a very quick survey as to the Longhorn client and some of the stuff that we're working on. I'm happy to take questions.
Will this run on IA64?
Yes, of 64-bit versions of all this stuff. Other questions? Yes? The question is, will this run on a PDA someday? How big is your PDA, sir? You know, one of the things that we're looking at is obviously with the .NET Compact framework and putting more and more functionality into this. Things like Indigo, certainly you'd expect to have client stuff on your PDA. As you talk about storage, having a storage work on your PDA a little more challenging because it generally requires a lot more horsepower in order for it to run. So that's a bit of a challenge. As it comes to the presentation framework, I can imagine that we would have a subset of that would work on PDA, on that type of device, but it would have to scale down significantly. We're doing some research into that area. I don't have a good firm design point on PDAs right now, but we expect kind of two trends in that space. One is that as these handheld devices become more and more powerful, being able to put full-on versions of Windows onto them, there's been a series of efforts around that. Having full-on versions of Windows that can be subsetted down by the OEM is something that we would see more and more. And then making sure that we have good portable versions as well, but focusing there on portable and not trying to over-push the device. So there's still work to do there. You had a question there, sorry?
Will the .NET framework be still a separate piece of the WinFX Longhorn environment? So what I'm trying to understand is, will there be a difference then on the WinFX environment from the .NET framework point of view? Would I need to have the .NET framework with WinFX?
Well, the question is how does, see if I can summarize it, how does the .NET framework and WinFX relate? On Windows Longhorn, there will obviously be already a CLR on there. We need one. So there is a CLR already. So you can consider the .NET framework to be a subset, and in many ways a proper subset of WinFX, because essentially any managed interface is part of WinFX. So it is a subset. It would go, essentially you can think about the .NET framework as the piece, the managed code piece that goes onto multiple operating systems. So it's a proper superset there. Yes, sir.
One of the biggest sources of cost in terms of the upgrade is the testing of existing applications that you may be migrating through versions to support the new operating system. Could you talk to any tools or analysis you've done of the Windows 2000 migrations done by companies that would be plans that you would have to ease that migration process in companies?
I can't speak to tools, but I can speak to approach a little bit on that and what we're trying to do. With respect to approach, we're moving towards much more of a side-by-side model in general for upgrade. We want to make sure that system components that applications are dependent on can be side-by-side and essentially version locked as appropriate. One of the things that we're spending a lot of time on going forward is making sure that on the managed code side that the appropriate components can be version locked and that you can specify for your application what versions of the components are required in order for it to run. And that there won't be kind of automagic upgrade without your knowledge, which rarely is a positive thing. With respect to existing Win32 code bases, we're trying very hard to ensure that those are touched as little as possible in building the new stack side by side. So from an architecture perspective, basically it's don't touch what you don't own and make sure that people have the capability to make all the components from the system run side by side. Now, the huge challenge there from a side-by-side perspective is working set going forward. I can imagine not in Windows Longhorn, but let's say 3 versions after Windows Longhorn where I have 4 different versions of the CLR and 2 different service packs, and I'm running all of them at the same time. This gets us into questions about using virtual machines instead and getting into the world where different apps can essentially run in their own Windows virtual machine, both from a security point of view and a migration point of view. So side-by-side eventually leads us there as its ultimate extreme. But I think we're trying to figure out how far we can go in that direction before it's wrong and we need to backtrack towards a little bit more sharing between applications. Does that answer your question? Yeah. Yeah, sorry. I'm not up to speed on the tools issues. Yes, sir.
There's been a whole lot of talk about security issues. And given how much of a focus that is, it seems like all the Longhorn projects are that out.
Okay, so I'll talk about security for a minute. Part of our motivation towards moving towards a pretty much managed code environment in Longhorn is to get rid of a set of exploits that are really native code exploits. Buffer overruns come to mind as the canonical example. We hope that there are no buffer overruns in managed code just because of the way it's designed. So that was one of the pushes in that space. The other fundamental approach that we've taken with managed code is we go back to the code access security model and get to a two-tiered approach for security. I can imagine that I have, much as I have today, a partially trusted application where, we use the example of going to a website that it's able to have some markup or some code to do some work, and that code is determined to be partially trusted. I should be able to put a button up on the screen without having full trust. But let's imagine that I then have an application which does require full trust. Let's imagine it requires network access, it requires local file system access to the system overall in an unprompted way. Well, that app would require full trust, and the user would have to give it essentially an installation access. So our model in Windows Longhorn is partially trusted happens, no prompt. Fully trusted requires a user prompt, and then there are certain conditions around that give the user a green, yellow, red model for whether they want to accept or not accept that. And there's a set of properties around that application that help us make that determination. Whether it's signed, whether it's coming over a secure service, maybe if there's additional testing done on it, what capabilities it has. But fundamentally, from a security perspective in the platform, we don't want to have kind of a menu where the user says, well, I want to give it this permission but not that permission. So what we expect is that it's either trusted and it can do a wide range of stuff, or it is untrusted and it has a narrow band. To that narrow band, we expect that administrators can add functionality to that. And to that broad band, to that trusted, we expect that network administrators and sysadmins can subtract from that. But we don't want to get into a wacky world where, depending on the user and the time of day, there's a subset of the APIs that will work or not work. Because from an application vendor perspective, that becomes impossible to debug and actually test and build. So this whole notion of what we call the C, or the secure execution environment, is intrinsic to essentially everything we're doing in Longhorn and the managed code side. There's a set of huge challenges in that space to actually get that right. I think specifically about sharing data. Like this is one of the scenarios that keeps me up at night, quite honestly, which is, let's imagine that I have contacts on my system. And those are good. Outlook handles them for me. I like it. And then I go to a website somewhere where it's, let's say, an extranet site, or not an extranet site. Let's choose a wacky example. Let's choose an internet gaming site. And that gaming site must have the capability, even in a partially trusted way, to generate objects in a schema. Like, they can generate people, because I want to have my contacts for that gaming site up there. Now, I can choose, when a dialog pops up asking me for people contacts, I should be able to choose seamlessly between those that this gaming site created and those that were already on my system. So the site should have access to my contacts in a user-directed way that were on my local machine, but always have programmatic access to the contacts that it itself generated for me. So you get into this interesting scenario where I have trusted and untrusted data interacting together, but need to be presented to the user in a common way. You need to decide what is user-directed file access versus, or data access, versus programmatic data access, and have different models for that. So otherwise, what we don't want to have happen is have this real strong wall between trusted applications and untrusted applications. Because what we found is that when you create that strong wall, it encourages people to build ladders and hammers to break down the wall a little bit so that they can kind of get around it and break it, and then it just opens up everyone to the attacks. So it is something we think about and spend a lot of time on, and I probably should have spent more time on it here today. No, and there's actually some work going on around really scaling back what's called the LUA effort, the limited user access effort, where basically apps are given less, where it's at the application level, not the user level, where applications are given user level trust, and only if they don't work do you try to grant them administrator access, so you don't have the propagation of administrator level access applications. But it's something we're spending a bunch of time on, and you probably heard a lot about Springboard. So it's something that's in our psyche. And the real challenge we have on this is that we want the C to be a useful subset. We don't want it to be so restricted and so secure that every app and everything that people run has to be fully trusted, because then we've totally failed there as well. So the basic bar that we think about today is, what are the things that you can do in HTML in the browser? Like a good example there is the file upload control. We were having a big debate about whether or not we should have user-directed file open and file save in the C. I said, yeah, because, boy, the browser's got it today. The file upload control, where I pick the file and it uploads it, it's there. Apps use it. If you take away that functionality, you're forcing applications to be fully trusted before they run, and then you haven't solved anything. So it's a huge challenge. So sorry, that was a little rant there. Internal challenge. Other questions? Did that answer your question, sir? Okay, you're welcome. Yes, sir.
How far are you going to support the concept of offline, in terms of application and data?
The question was about offline and how far we're supporting it. I think we're doing okay right now on the programmatic side, on getting your code down and having guaranteed code offline. I think we're not doing so good on data offline and having the right synchronization managers to bring your data down. I think there's a lot more work left in that space. Basically, the position we're at today is we can bring your app down and make sure your app's going to run and make sure it runs persistently over time. It's going to be up to the business object that accesses the data to do the right thing about bringing the data down and syncing it, because there's just a ton of challenges there to doing the right thing. So,
Are you going to take care of that in the long run?
question is, are we going to take care of that in the Longhorn timeframe? We might make it a little bit better. It's an area of focus. Every time we get close to it, it gets a little scary. So I'm not sure how automatic we're going to make data. So it's a good challenge. Other questions? Yes, sir.
In your document on Avalon, you identify three different models: document, UI, and media. Can you talk a little bit about those and how you're positioning those?
Okay. The question was, as we were talking about document, UI, and media areas in Avalon. So I talked before about integration. One of the central visions for Avalon is integrating user interface documents and media, because one of the trends that we see is that there are experiences that people have today where it's not clear whether the thing that they're doing is a document, is a piece of multimedia, or is a user interface. There's many, many, many examples of that, mostly on the web today, and in many line of business applications as well. So what we wanted to do was to make sure that there were document features, UI features, and media features intrinsic in the platform, and that you program to them in the same way, and that the user experience for them was the same, and that the developer experience was the same. So can I have a piece of UI application that's in the browser? Absolutely. Can I have a document that's in a standalone window? Absolutely. Do I program to them in the same way? If I have an image object or a text object, do they source events the same way? Absolutely. So we have a rich document platform which does fixed format documents a la PDF, as well as flow-based documents with pagination and columns and that sort of stuff. Have a full user interface platform to do essentially all the controls that you could imagine. I talked a little bit about that before, as well as a full media platform for video, for audio, for syncing, for animation, as well as a full-on graphics infrastructure to make that work. Hopefully world-class in all those respects, but integrated in a common way. That's the 2-minute version. Other questions? Okay, so with that, I'll thank you for your time and hope you enjoy the rest of the conference. Thanks a lot.